Hello, and welcome to variables in Rust. A variable is a location that holds data for us. So when we create a variable, we're basically telling the computer to put something in memory. For example, my name is Ebby. So let's define a variable. Let my name equal Ebby. So now we've effectively put the string Ebby into memory, represented by the variable my name. Now let's print this to console and see what happens. So print line exclamation point. My name is, and here we'll put two curly braces. Now whatever variable we put here will be inserted into where these two curly braces are. So now I'll finish it up with a semicolon. So now I'll save and change over to the terminal. And to compile, we'll write rustc space and then the name of the file. In this case, it's variables.rs. So now when we run the executable, we see that it says my name is Ebby. For efficiency's sake, variables in Rust are not mutable. This means they cannot be changed. If I later want to change what this variable holds, then I should add the mute keyword. In this case, let mute my name equal Ebby. So now that we can change the value of my name, let's change it to Tom. So I'm going to copy and paste the print line and recompile. So first we see my name is Ebby, and then we see my name is Tom. And this is a result of our instructions being run in sequence. There are also constants, and these are defined with the const keyword. So const pi is equal to 3.14159. So consts are not a location in memory, unlike variables. Consts only define an alias for a certain value we want to use throughout the code. And this cannot be changed in runtime, meaning while the code is running, the value of a const cannot be altered. Now there are various types of variables and constants we can have. As you noticed, I put an F32 here. This stands for a 32-bit float. There are signed integers, unsigned integers, floats, characters, strings, and booleans. It is useful to define what we are using our consts and our variables for. And especially in the case of variables, it is useful to define how much space they're meant to take in memory. For integers, the various sizes are 8 bits, 16 bits, 32 bits, 64 bits, and 128 bits. There's an additional I size or U size, which is machine dependent. There are fewer options of floats with either 32 bits or 64 bits. Whereas chars take up a single character and are effectively 8-bit. Strings, on the other hand, take up many characters. And one good example of this was the my name from earlier, which implicitly got defined as a string when we put Ebby into it. And lastly, booleans are the smallest of them all, holding a single bit, a 0 or a 1, representing true or false. Now there's one distinction between signed and unsigned integers, and it's a very important one. Signed integers can be negative, positive, or 0, but unsigned integers can only be positive or 0. The signed integers use one of their bits to store information as to whether or not the variable is negative. Given that integers are whole numbers, every bit that you add on doubles the maximum possible number it can hold. So effectively, unsigned integers can hold approximately twice the largest number of a signed number. So let's see this in action. So let's print line again, and we'll write signed, open and close curly braces, unsigned, open and close curly braces, and now we're going to put I8 : max to get the maximum 8-bit signed integer, and we're going to put U8 : max to get the maximum 8-bit unsigned integer. So saving and recompiling, you can see here that signed gives us 127 with 8 bits, and unsigned gives us 255, also with 8 bits. There are certain limitations with integers to consider, and that comes down to really division. When you divide two integers, you'll drop anything that comes after the decimal place. So let's see that. So now what I'm going to do is I'm going to write print line exclamation point, and I'm going to put 1 divided by 2 is equal to, and then the two curly braces. And now this time, instead of putting a variable, I'm going to put an expression here. So I'm going to do the number 1 divide by 2. So here you can see it says 1 divided by 2 is equal to 0. And that's because it dropped the 0.5. So now I'm going to change it to 3 over 2. I'm going to save, compile, and run again. And you can see here it says that 3 divided by 2 equals 1. Again, it dropped to 0.5. So when you're dealing with integers, remember, anything that follows the decimal point is gone. So that's where we might want to use floats. But where floats can handle decimal points, there's an issue with imprecision in math. But that topic warrants its own video, so we'll discuss that later. But with variables covered, we have our first building block for Rust development. Alright, but that's all for this topic. I'll see you in the next lesson.